Hello everyone and welcome to Module 5. In Module 5 we'll cover t-tests, both independent t-tests and dependent t-tests. So let's first talk about the basic logic of group differences. A lot of our research questions are about group differences. So for example, did treatment differ from control? Do men and women differ from one another? Do people who get a treatment do better after treatment than they did before treatment? And in all of these, we want to know if the difference between the group means is greater than 0. The null hypothesis is that the populations are essentially the same. In other words, there's no difference between the groups or between the population parameters. The population means is what we're estimating here. So if the difference between the sample means is large enough, or if a difference of this size is unlikely, assuming that the null hypothesis is true, we'll reject the null hypothesis and conclude that there is a difference between the populations. And so when we think about the inferential logic of t-tests, we're interested in the difference between two independent groups, and so we're comparing two populations by evaluating the mean difference. And so in order to evaluate the mean difference between two populations, we sample from each population and compare the sample means on a given variable. And so we must have two groups, that should say groups, samples or times, for example, as the independent variable, and one dependent variable that is continuous to compare those groups on. So for example, we may ask, do males and females significantly differ on their level of contraception self-efficacy? We'll come back to this question, but the independent variable here is biological sex. We have two groups, males and females. And our dependent variable is level of contraception self-efficacy. So again, you can see here how we look at this research question and we can tell immediately what the independent and dependent variables are. Another example is, do older adolescents drink significantly more frequently than younger adolescents? Again, our independent variable here is age, and age is a continuous variable, obviously, in its raw form, but we can actually categorize age, older adolescents and younger adolescents, and we may choose different ways of categorizing that, so maybe 12 to 15, 16 and up. That would obviously depend on what our rationale was and what our thinking was about why there might be differences between older and younger adolescents. And our dependent variable is the frequency of drinking. So that may be number of days drinking, number of days of heavy drinking, whatever we're looking at here. So t-tests are one of the simplest ways to examine these group differences. T-tests are based on a set of distributions that in some cases are similar to the Z distribution, which we talked a little bit about in lectures and which you read about extensively in your texts. The shape of the t distributions changes depending on the number of degrees of freedom available. So the z distribution is a single distribution that we look at. The t-tests are a set of distributions that change shape according to the degrees of freedom. We'll come back to degrees of freedom in a second. Degrees of freedom for independent samples t-tests are the total sample size minus 2, or each of the individual group sample sizes minus 1. Those are the same number. And the greater the number of degrees of freedom, the closer the t distribution approximates the z distribution. So here it is in a picture format. We see what this standard z distribution looks like here in blue. This is a t distribution with an n of close to 30, and so we see that it's fairly similar in a lot of ways. And this is a t distribution with an n that's smaller than 30. So we see how it gets a little bit farther away from what the z distribution looks like as the sample size gets smaller. And we'll talk more about the ways in which the sample size affects the assumptions that we can make about the t-test. So degrees of freedom. This is, I find, a really difficult concept to understand, and so I'll try and say it in a couple of different ways. Lucky for us, SPSS just handles degrees of freedom for us, so we don't have to spend a ton of time thinking about this. Degrees of freedom are the number of values that are free to vary in calculating a statistic. Perhaps a simpler way of thinking about this is that the number of parameters that we're trying to estimate in a given statistic. And most tests have a number of degrees of freedom associated with that test, a standard number of degrees of freedom associated with the test. For an independent samples t-test, each sample mean places a restriction on the value of one score in the sample. So the sample lost 1 degree of freedom, and there are n minus 1 degrees of freedom for the sample. So n minus 1 for each group, or the total sample size minus 2. Perhaps the simplest way to think about this is in an independent samples t-test, we're trying to estimate the two population means. Using our sample means, we're trying to estimate what those two population means are. So the degrees of freedom is 2, the number of parameters that we're trying to estimate. I think that's a simpler way to think about it, perhaps. So the t-test, as with all statistical tests, come with a number of assumptions that we need to make sure that we have met to some degree to move forward with our t-test. For independent samples t-test, we want to make sure we have independence of observation so that our groups are independent of one another. And so this may be entirely different samples that we're looking at. In many cases, we're looking at individuals that we have split into different groups in the same sample. So men and women, different age groups, people based on certain characteristics, drinkers or non-drinkers, those who are sexually active versus those who are not. And those groups are still independent observations. They don't depend on one another. We'll talk later about the dependent measures t-test, and there are groups that would be connected in some way, like husbands or wives, or pre-test and post-test. But our groups for independent samples t-test should be independent of one another. The level of measurement of the dependent variable should be interval or ratio, a continuous variable. And the independent variable is categorical, or can be made categorical, as we saw with the age example from before. And the levels in that categorical variable, there should only be 2 groups. If we have more than 2 groups, we'll talk next week about ANOVAs, which is a way to examine mean differences when you have more than 2 groups on your categorical independent variable. So for the t-test, we can only have 2 groups in that independent categorical variable. We also want to try and make sure that we have equal variances between our groups, so that for men, for example, and for women, within the group of men, the variance in the dependent variable is roughly the same as the variance on that dependent variable within the group of women. This is called homoscedasticity. Say that 3 times fast. And so this is an assumption that we make. The t-test in SPSS gives us an option for a different version of the t-test that accounts for unequal variances between the groups. And typically when our group sizes are fairly equal, the test is fairly robust to this violation. So this is not one that we think about a whole lot, to be honest. We also want to make sure that our dependent variable is approximately normally distributed. And again, when our sample is large enough, the test is also fairly robust to a violation of this assumption. We often talk about large enough being 30 to 40-ish people per group. Certainly for the AdHealth data that we're looking at in this class, we far surpass that for most of the variables that we're going to be examining. So let's talk about conducting and interpreting t-tests and get a better sense of what those mean. So your Huck book talks about a variety of stepped processes for testing, answering a research question. For the purposes of this example, I'm going to give you this 4-step process. So state the null and alternative hypotheses, ensure you meet the test assumptions, calculate the test statistic, and make a decision and interpret your results. I'm lumping several steps into here into single steps in this situation, but you guys get the sense of this process. So in the first step, we want to state the null and alternative hypotheses. So our null hypothesis is that the population mean of one group is equal to the population mean of the other group. So the null hypothesis asserts that there is no significant difference between the population means on our dependent variable. So men and women are the same, younger and older adolescents are the same on whatever our outcome variable is. Our alternative hypothesis is that there is a difference between the population means, and we could have a non-directional hypothesis, just that the groups are not equal, or we could have directional hypothesis. So in this one, group 1 mean is higher than group 2 mean, or in this one, the other way around, group 1 mean is significantly lower than group 2 mean. Typically, we want to phrase things, we can phrase things in specific ways according to what our rationale is. Almost always, we are running a two-tailed test for this. SPSS runs two-tailed tests, so most people will just conduct a two-tailed test, even if they have a specific directional hypothesis. So then we want to check that our assumptions are met. So first we want to make sure we have independent observations, as I talked about before, that our levels of measurement are appropriate for a t-test, that we have equivalency in the size and variance of our two groups, and that there's approximately a normal distribution on the dependent variable, or that the sample size is large enough that that doesn't matter so much. And our third step is to conduct the test. Lucky for us, we have SPSS, and so we don't have to sit and plug everything into these formulas. And for the purposes of this class, I'm not going to ask you guys to calculate all of these things by hand. I think it's more important to understand how to do these things in SPSS, how to make the decisions about what test to use, and then how to interpret those results. But your book has these calculations. Some people put the formulas in slightly different formats. They're roughly the same, they just lay things out differently in different orders of operation, but they all give you the same answer. But this gives you a sense that what's on the top here is this difference in the group means. So the group mean for group 1, the group mean for group 2. And then this deals with the variance and the degrees of freedom that we're using in that calculation. And step 4 is making a decision. And so if we remember back to our distributions and how we think about making these decisions, if our test statistic falls somewhere in here, we would fail to reject the null hypothesis. We would assume that the test statistic that we found is due to chance, that it could fall anywhere in here based on how we expect the distribution to look out in the world. If it falls over on one of these tails over here, we would reject the null hypothesis. So we may fail to reject the null hypothesis and conclude that there is no statistically significant difference between the groups on the dependent variable, or we can reject the null hypothesis and conclude that there is a statistically significant difference between the two groups on the dependent variable. And if it's directional, we want to indicate which group is higher or lower, greater than, less than, etc. And then we want to think about how to interpret that. So we always want to think about the value of the alpha. The higher the alpha, the more likely we are to reject the null hypothesis. We want to think about the size of the sample. The larger the sample, the more likely we are to reject the null hypothesis. And in with this, we want to think about the size of the difference. So what are the means? What is the difference between the means? And what is the scale for that dependent variable? So what does that difference mean? So if we're looking at number of partners, for example, and we find a difference of 1. So for example, men report 1 more partner than women. Is that important? We would want to think about what the average numbers of partners are for a lot of people. If out in the population, the average number of partners is something like 2 for most people, then a difference of 1 maybe is something that we want to think about. That's twice as many, right? And so if we're looking at something on a scale of, people could score anywhere between 5 and 20, a difference of 1 may not be that important. And so we want to think about the size of that difference. Even if the difference is fairly small, the larger our sample size is, the more likely we are to reject the null hypothesis, to find a significant difference between those two groups. So we want to keep all of these things in mind as we're thinking about interpreting the results of our t-test, or any statistic for that matter. And we also want to think about the clinical practical significance. So if somebody has a difference of 1 point on a particular scale, is that 1 point in a place that would put them above or below a diagnostic criteria? Is it something that we would consider a success clinically if we could move somebody 1 point on a particular scale? Or would that not be something that we would consider important or clinically or practically significant for us? So all things to think about as we interpret the results of our analyses. So I'll show you a full example in SPSS to help you think through how we create the research question and how we move through each of these steps using a concrete example from the AdHealth dataset. So our first step, obviously we would have our research question before, but to state the null and alternative hypotheses. So coming back to this question that I gave as an example in the beginning, do males and females differ in their levels of contraceptive self-efficacy? And so our null hypothesis would be that the population means for men and women are the same, equal to one another. And so males and females do not differ in levels of contraceptive self-efficacy. Our alternative, or our research hypothesis, if we went non-directional, we could say that males and females they're not equal, essentially. So males and females do not or do differ in levels of contraceptive self-efficacy. We could also go directional, and maybe we might want to say that females have higher levels of contraceptive self-efficacy than males. So maybe it is that women are the ones who are in charge of many kinds of hormonal birth control, and we could think about some of the gatekeeper hypotheses around male and female sexual interactions and say maybe females have higher levels of contraceptive self-efficacy than males. In the reverse direction, we might say males have higher levels of contraceptive self-efficacy than females. If we think about traditional heteronormative power dynamics, we might speculate that males would have higher levels of self-efficacy because they tend to have more power in heterosexual interactions. So those are what the hypotheses would look like for the null and alternative. And so our third step, or our second step would be to check our assumptions. But before we do that, let's do a quick aside. And many of you are looking at this, are interested in this contraceptive self-efficacy scale for your individual papers for the course. And so before we even start looking at this, we actually have to fix and create a total contraceptive self-efficacy scale. So the first thing that we need to do, this scale is coded such that a response of 6 indicates that somebody said, I don't want to use birth control at all. I'm actually just not interested. And so for them, self-efficacy is not so relevant. We don't want to know if they feel confident that they're able to use birth control even when they're highly aroused, when they don't want to use birth control. So we're going to take those people out of the equation, or take those responses out of the equation. So we want to recode. These are each of the individual 3-item variables on this scale. And so we want to make it so that everybody who said 6, we're going to give them a 9-9. We're going to make them missing. So this is the syntax behind that. But then we also need to tell SPSS that 9-9 is missing. And so SPSS in this data set already has 9-6, 9-7, and 9-8 as the missing values that they already had programmed in there. SPSS doesn't like for there to be more than 3 individual missing value codes, and so we have to do a range in here to tell it that everything from 9-6 through 9-9 is missing for each of these. Otherwise, it will use 9-9 in calculating our means and our totals. And then we have to get a total score. And so we can do this in a variety of ways. If you do some literature review on the use of this scale, or the use of these items, you'll find people who do it in a few different ways. One of the better ways that I have found of doing it is this paper, and I can upload this paper or give you the full citation if you're interested in it. And they suggest a calculation of the mean using at least 2 of the 3 values. So some people have a refuse to answer for 1 of the 3 values, or 2 of the 3 values, for example. And so we only want to calculate a mean for people who answered at least 2 of the 3 values. So this piece of the calculation right here, mean.2, means that I want to get a mean of these 3 items, but only if there are at least 2 valid responses across these 3 items. And so then they recommended doing a mean of at least 2 of the 3 values and then multiplying that mean by 3 for a total score. So what we could do is just get a total score and just add up all 3 of these. But what that wouldn't do is account for those people who refuse to answer 1 of those questions. In some ways, this kind of accounts for some of the missingness and gets us around some of the missing issue in some way. So we would want to, this is the syntax to do that. And so you have that now for those of you who are interested in using the scale. So you want to compute this new variable, which I've named contraceptive self-efficacy. And this is how the calculation that you want SPSS to use to do that. I want to label that variable. So this is the variable that I want to label, and I want to call it contraceptive self-efficacy, and then execute. So that's an aside. So we did our research question and our hypotheses. We calculated our self-efficacy scale, and now we want to check that the assumptions of the t-test are met. So do we have independent observations? Yes, males and females are independent groups. Are levels of measurement appropriate for a t-test? We have a continuous dependent variable, the scale score on the contraceptive self-efficacy, plus a categorical independent variable, males versus females. So we're good on the levels of measurement. We want to check for equivalency in size and variance of groups. We have, for those who have valid scores on this outcome, we have 1,806 males, 1,917 females, so roughly equivalent. We'll check the equality of variance in the t-test. That will give us that calculation. And then we want to check to see that we have approximately normal distributions on the dependent variable. And I'll show you those on the next slide, but they're meh. We have some skew and some kurtosis in there, but this is a really large sample, so we actually don't need to worry so much about that. So we check these normality assumptions by running our measures of central tendency, our mean, our mode, and our median, and then look at the skewness and the kurtosis, and also look at a histogram. So this is what we get when we do that. And if we look over here, our mean and median are fairly similar. The mode is a little bit lower down here. And if we look at our skewness, the raw values are actually in a pretty good range. If you look at the significance testing, where you divide the skew statistic by the standard error of the skew, these are actually fairly high. But again, we have a very large sample, so we're not going to worry so much about the violations of the normality assumption here. So this is how we would evaluate that assumption. So the third step is to conduct the test. Again, you can do this via drop-down boxes on SPSS, but this is the syntax behind that. So this is running the group. When you go to put in the group, it'll ask you to put in your independent variable, which is biological sex. And we want to be able to tell SPSS how those groups are coded. So in this case, males are 1, females are 2, and so you just want to tell it that the groups that we're looking at are 1 and 2. And then we want to tell it what variable that is, and we're using a 95% confidence interval. This is all standard to the t-test, so really all you have to do is put in this outcome variable here and put in the independent variable and tell SPSS how it's coded. So then when we look here at the output that we get, what are we looking for here? So we have two boxes that pop out for us on the t-test. This first one gives us our group statistics. So this is just the mean and the standard deviation and the sample size for each of our groups. So again, we already knew 1806 and 1917. These are our means, 5.66 and 4.78. And these are the standard deviations and standard errors of the means that are associated with each of those means. And what the t-test is telling us again is this difference between 5.66 and 4.78 a difference that is large enough that we think it didn't happen by chance? So the t-test then down here, this independent samples test, is divided up into two different portions. So this portion over here, the Levene's test for equality of variance, this is this test that tells us whether the groups have equal variance. And so whenever we have a significant test here, we want to look under equal variance is not assumed. So this tests whether the difference between those groups in the variance is significant. It is, so we want to use the equal variance is not assumed row right here. If this is not significant, if p is greater than 0.05, then we will use the equal variance as assumed row and report the statistics from this row. In this situation, even though we are using the equal variance as not assumed row, we can see that they're actually pretty different. 11.11 is the t statistic when we assume that equal variances are in place, and it's 11.07 when we don't. So these are fairly similar. Part of what this calculation does is adjust the degrees of freedom. So you will get a different number for the degrees of freedom here, but we still get the same significance value. The mean difference between the two groups is still the same. We see some adjustment in the standard error of the difference and in the calculation of the 95% confidence interval. And so what we're seeing here, and I'll actually show you what we look at, how we put this in a table, but what we're seeing here is this T statistic, 11.07, and here's our degrees of freedom. So if we were to look this up in a t-test table, we would be able to use the degrees of freedom here and our p is less than 0.05 significance level, and we would be able to tell from that table that this is in fact significant. SPSS luckily tells us, so we don't have to go to any tables, we don't have to do anything else. What we know here is that p is less than 0.05 and in fact is less than 0.001. That's the best that we can know from a significance value of 0.000. So if we put this in a table, what this would look like is that we would report biological sex, male, female, the levels of contraceptive self-efficacy for each group. So here's the mean and the standard deviation, the mean and the standard deviation, and here is our t-value. And in most tables, we'll use asterisks. Some tables will actually give the exact p-value, particularly if you're reporting on a range of statistics, and then down here we give a sense that 2 stars means p is less than 0.01, 3 stars means p is less than 0.001, which it is in our situation. And so going into step 4 in terms of making a decision interpreting the results, how do we use that information to determine whether or not we reject the null hypothesis? So p is less than 0.05, and so we reject the null hypothesis. Our t statistic here is 11.07, p is less than 0.001. And if we were to write this up, we could obviously write it in a variety of different ways, but we could say we'd want to give some information about what the scale scores are. So contraceptive self-efficacy scores range from 3 to 15. Here's the group, the mean for the entire sample and the standard deviation for the entire sample, with higher scores indicating lower levels of self-efficacy. So again, this is why we always need to remember how the scale is scored and what those scores mean. So males scored significantly higher in contraceptive self-efficacy than females, and we can give the group means and standard deviations, and then our t statistic here, indicating lower levels of contraceptive self-efficacy among males when compared to females. So we want to give what those comparisons are and interpret what that difference means. So because higher scores indicate lower levels of self-efficacy and men scored higher, it indicates lower levels of contraceptive self-efficacy among males when compared to females. You know, that's a lot of double negatives. And what some people will do is reverse code something. So they'll flip everything around so that it may, maybe we ask them in a particular direction, but we can flip that around so that we can interpret that in a way that is less double negative-y. But this is essentially what we would say to report this result. But we also want to think about what a difference of 0.8 means on a scale whose scores range from 3 to 15. So is that important? You know, how do we think about what that difference means for people? Is that clinically relevant? If we're thinking about using self-efficacy in therapy to try and build people's self-efficacy, do we need to know that men and women differ by 0.8 on that scale? What does that tell us? So maybe that's not so important of a finding, even though it is highly significant. So again, we can see how we need to think about the distinctions between significance and importance here. So that's the basic process for an independent samples t-test. But in many situations, we have dependent samples, in which case we would run a different t-test. And the logic of the dependent samples t-tests is that we have dependent or related samples. And so we may measure the same group twice. So for example, time 1 versus time 2, pre-test and post-test, or sometimes samples are matched on some variable. Your book describes how people might do that. Each score in one sample may be paired with a specific score in the other sample. So for example, husbands and wives, fathers and sons, you know, things like that. And so these data are actually correlated data, and so we want to run a t-test that will account for the relationship between each of these scores. So we may ask different kinds of research questions that would lend themselves to a dependent samples t-test. So for example, is there a significant difference in safer sex self-efficacy before and after our participants receive a training that's designed to improve their self-efficacy? So rather than comparing the means of the pre and post-test scores, we actually want to compare the pre and post-test scores for each individual. So we're looking at change for each individual in this situation. So our independent variable is actually time before and after, and our dependent variable is still the same, the safer sex self-efficacy scores. And so again, we want to state the hypotheses, but these are stated a little bit differently. We're not looking at group mean differences here in terms of pre-test versus post-test or men versus women. We're actually thinking about the difference score. So the subscript of D indicates difference. So in our null hypothesis, we would say that the population, the difference between population means, so whether that's pre or post or whatever, is 0, that there is no difference. And our research hypothesis, again, we could do non-directional or directional. For these situations, I think the non-directional typically makes the most sense. That this difference between pre and post-test is not 0. So that we do think that people changed from time 1 to time 2, from pre-test to post-test. We may not know which direction. We often, in many of these situations, hypothesize that that difference is greater than 0. We think that there has been some change, depending on the scale, depending on what we're looking at. We may say it's less than 0, but typically we're going to do something non-directional or that it's greater than 0. Again, as with the independent samples t-test and as with most analyses, we're typically running a two-tailed test, even if our hypothesis is directional in some way. So again, we want to check our assumptions, and luckily for the dependent samples t-test, our assumptions are exactly the same as for the independent samples t-test, with the exception of having independent groups. So the independence of groups assumption is obviously not met in this situation, which is why we use a different t-test entirely. Otherwise, those assumptions are still the same. So we want to still go through the same process of checking normality unless our sample size is large enough, making sure that our variables are good in terms of being continuous, etc. And then we want to compute the test statistics. You can see that the calculation for this t is very different than it is in the independent samples t-test. So we're using a totally different formula here, but it's still based on the t distribution. And again, you don't have to worry so much about this. I want you to get it conceptually, but we are going to use SPSS to calculate this, and so we don't have to worry so much about the details of this. And then same fourth step, we want to make a decision and interpret those results. So again, thinking about what our p-value is, what our critical value is, and consider the size of the difference, and then think about significance versus importance. So essentially the same steps that we use, but again, we're talking more about different scores here, so we're not necessarily looking at the mean of pre-test versus the mean of post-test. That doesn't really tell us anything because it doesn't tell us how individual people may have changed from that first time point to the second time point, which is typically what we're going to be talking about in these kinds of analyses. So hopefully that gives you a good sense between that and reading the 2 chapters of the independent and dependent samples t-tests. For the Module 5 assignment, which is posted on Campus Cruiser, you'll download the data set and answer the research question proposed in the assignment. There is a PDF of the assignment that gives you a research scenario, which is actually a research scenario that is from a data set that I am in the midst of analyzing right now, or it's on my back burner to analyze anyway. And so this was a feasibility and acceptability trial of an expressive writing intervention that I recently conducted. And so the assignment itself gives you the scenario, gives you a little bit of background on the methods, and poses a research question that I want you to answer using what you know now about independent samples and dependent samples t-tests. So you'll download that data set, look at the assignment, and answer the research question using either an independent or a dependent samples t-test. You'll have to make that decision. And you'll write up a results section. There's no table necessary for this one. You can do everything in text. but this needs to be in APA format. You'll need to report the numbers in APA format and write up a results section, making sure that you're interpreting the analysis, that you're justifying that analysis. So tell me what you're choosing, tell me why you chose that, run the statistic, report on that, and then interpret that. And there's a grading rubric in the assignment as well, and all the links to that are in the Module 5 content. And as always, let me know if you have questions, thoughts, post under the general discussion forum, and I'll see you in Module 6.